night. Green light. All right, cool. Waterfalls. So here's your exponential growth model, decay model. Remember, they pretty much look the same here, right? All we were looking for, we're changing here is from that function notation looking like an equation type notation. What determines your growth decay? There's two things, right? Yeah, the KT is going to determine, right? If K is negative, then you have decay. What else can you have? If A naught is a decimal between, or yeah, a decimal. I shouldn't say a decimal. It should be some decimal between 0 and 1. Because like 1.5 is technically the decimal. So it's going to be some decimal or fraction that's between 0 and 1. That will give you decay as well. Cool beans. Any questions here? Moving on up. And here we go again. So if K is greater than 0, then it's growing. If K is less than 0, then it's decaying.
I have a question.
Mm-hmm.
Can you go back one?
Yes.
Like, go back one? Oh, when you're done. Is that what we're waiting for?
No, you said it was a question. It wasn't a command.
I said, can you go back one?
Yeah, but it was a question. I answered your question.
Oh, okay.
I'm being silly.
Those
Yeah.
are the same thing, right? The FT and the A equals?
Yeah, it's kind of, if you think about it like y and f of x, they're kind of equivalent.
Okay.
In this case, you have a function notation, while over here it's kind of a equation type notation.
That's it.
Yes. Remember, it's that positive exponent. Now, technically, what should k be greater than? Well, actually, I take that back. The only time you're going to get something that doesn't grow is if k is 1 and t is also 1. Because 1 times 1 is 1, making that exponent 1. And then that's just going to take that base value and leave it alone. Right?
It's just going to be a line.
Yeah, it would. Well, yeah, it would be just a line. That's why you definitely want it to be greater than 1. Or greater than 0 at least. Because if you do 0, then that's totally out of the ballpark. That would also be just a line. You're good though? Okay. So here was that. Growth, decay. Too many side conversations? Thank you. Focusing. I was telling somebody I'm going to get a Nerf gun. The one that shoots a little darts and just like shoot people.
That's my dad.
Right? Pop, pop.
I'm going to actually, I'm just going to be paying attention when we get talking. Damn, Madeline.
Whoa, watch your words, please.
Dang.
Isaac. Here we go. Are we good? You guys ready for the next one? Here's your first problem. So here we have an application problem. In 2000, the population of Africa was 807 million. And by 2011, it had grown to I knew it was in millions and I wanted to say the number and I couldn't process it. It's 1,052 million. Use the exponential growth model. A is equal to, what's up?
There's a question. If A is a number less than 0 and KT is a negative, would it be positive?
Yeah.
Okay.
Isn't that trippy?
Yeah.
Yeah. She's saying that if your A naught is some value between 0 and 1, which is doing decay, but K is also negative, then that's decay. Decay and decay actually makes you have growth going, which is trippy. I don't know, but I don't think I've seen like a problem that actually does that, but theoretically that's what's going on. If A naught is some decimal and K is still negative, then you actually have growth. All right, let's get back to here. So use the exponential growth model. A equals A naught e to the kt, in which t is the number of years after 2000. Find the exponential growth function that models this data. Ooh, trippy, huh? Yeah? Yeah. Okay. So, what's A naught? That's going to be the first decision, right? What is it? How do you know? That's where you started, right? That's the starting point. So this is going to be 807. E is a number. I can find that. Do we know K? No, we don't know K, do we? K is going to stay, but we do know T. And what is T? It's 11. Can we solve this? Can we solve this? We're going to have to solve for K, but we have two variables. Now, you guys remember the rule, right?
Oh, wait, we should do natural.
Isn't T like
Waterfalls real quick. Just want to remind you of some rules. If you have one equation and you want to solve it, there can only be one variable. You cannot have two. That's going to produce a model for you. Okay? One equation can only have one unknown if you want to solve it. If you have two unknowns, then you need at minimum two equations. Three unknowns, you need three equations. Four unknowns, you're going to need four equations. In this case, we only have one equation with two unknowns, A and K. Can this be solved? Go ahead, Lily.
Isn't the A 1,050?
Yes, because remember, what did you guys say? It's 11 years later? So this is what we end up with after 11 years. So that means that A is going to be our 1052. So now we have 1052 here. And now we can solve it for our K, which is our rate of growth. Okay? So how would we do this? First step, what would you take? Divide. By? Yeah, exactly. 807. 807. That'd be gone. Come on. Oh, don't do that. Blech. I don't like when it does that squishy page. The more you write, the smaller the page gets, and it gets like a long strip, which is really trippy. So this is going to give us E to the K, or I should do 11K, huh? You guys cool with that? 11K. And then what's this quotient? Is it gross? I'm going to leave it alone then. 1052, 807. Now, how do I get rid of that E? I'm going to natural log this bad boy. So ln will make this go away. And now I'm going to get ln 1052 over 807 is equal to 11K. And to get K by itself, what should I do? Divide both sides by 11. So that'll give me 1. So K is equal to this quotient. So once I do find a number, and I would wait till the end so that I can try to get the most accurate solution. That make sense? Yeah, so technically right now, this is at its most accurate because I haven't rounded anything. Like I didn't divide here and then write that number down and then divide by 11. That would change stuff. With exponential growth at K, that really does matter. It matters a lot. Okay, so now let's go ahead and find some value for this, please. Let's find some value for this. Don't y'all rush to do it now. You're going to hurt your fingers. I need some value for ln 1052, 807 divided by 11. What'd you get? What'd you get? 0.024?
0.024102.
That's good. So here we go. So our K, in this case, is 0.024. What's that telling me about my problem? Am I growing or am I decaying? I'm growing. Why am I growing?
It's not less than 0.
It's definitely bigger than 0. Okay? So here's the model. The model in this case would be A equals, not A naught. What was A naught? 807. So here's our model that we can use now to predict what they asked us, which was to, oh.
It just says to fix your
Yeah, there it is then. Let me do the whole screen for you. you guys can write it down. Okay? It's been too long.
What was I saying?
Because they're not sneakers. They're not for basketball. These are running shoes. And man, I remember when I first got my first pair, man, I felt like I was running on clouds. Like, oh dude, I could be on these all day. Okay. Oh, that's not what I wanted. Okay.
My flannel days are over.
I want you to find this, the answer to this. When will the pop reach 2 million? 2 million? 2,000 million. 2,000. Is that even? That doesn't sound right.
Isn't it? I don't like it.
2 billion.
Yeah, but I just want to do it. I want to keep it in the same notation that they did. So this is 1,052 million. When is this? When will the population reach the 2,000 million mark? It does. But the way that they're doing the notations, it's like this is 807 million. This is technically 1,052 already. Go, go, go. I'm going to have this dojo call somebody. One minute.
I think we enter the 2000.
Only because I'm like the biggest baby when I get sick. I stubbed my toe and I'm crying. I want to die. I can't get sick. My wife says she don't. Because I'm the biggest baby. Like I really like all I want to do is like sleep on the couch, play video games. Like man, make me some caldito de pollo.
My Spanish translation.
I'm done with you, Riley.
Yeah.
Why you tripping? Why you tripping? I ain't even saying nothing. Wah, wah, wah. All right, question goes to. Hold on. One more minute.
Yeah.
That's a lot of time. But all right.
Is it ready? I'm sorry.
Hey, is the assembly outside?
Yeah, I think so, yeah. There's an assembly?
Yeah, it's outside on the bridge.
Is it really?
Oh, it's just right here?
This is for congratulations.
This is the Olaski.
They were like, guys, what's the last minute of soccer?
So we're right.
On the bridge though. On the bridge. Yeah. That was like 2015 or something.
Hey, yeah. Caleb. email, don't worry about it. Get it done when you get it done. He had the same issue too. It wasn't working. I think it was down for maintenance. But whenever you get it done, you get it done. Alright, that's time. That's more than 2 minutes. Question goes to Lauren! Hey Lauren, what'd you get? When will it happen? Waterfalls. When is it gonna happen? 2038. Can someone verify that? I got one. Can I get a second? Well, you did it together, right? 2038? Yeah, good job. In the year 2038 is when that population will reach the. In September. I love that. That was good. Why September? Is it because? Oh, it was what?
2037.
It'd be like
The year's
If you rounded it,
It would have been 82 years.
You can't just round up a year.
Yeah. Well,
It'd be like November.
You gotta do it in months.
hold on.
It would be like in the very.
Hold on.
2037.
So here's what you should have done. Oh, what the did I just do? I don't like that. So here's what you should have done. We have our model. Ladies and gentlemen, it's expectation right now. Do we need to go to our freshman objective? Talk about professional courtesy, culture. Some professional courtesy. Please, silencio. So we're looking for our pop to be here. We are here, and we know that our growth is going to be 0.024. So we're looking for time, right? That's going to give me the time in years after what? After 2000. So we're going to divide 807. Then we're going to take ln on that. So ln 2000 over 807. And then finally that'll be divided by 0.024 at the end, right? That should give me time. So I'm going to throw all that in the calculator. I should have had it ready. That's my bad. Did it open? Nope. Here we go. So here's how you can do that on here. We're going to make a fraction. And then I'm going to do a ln of a fraction. What was it? 2000? Over 807? 807. Close this bad boy. And then we're dividing by 0.024. So we're going to get 37.81 years. So it's going to happen in actually, if we did round off the year, it would be 38. But this would be what, 2000? 2000.
Late November 2000.
What's 80% of 12?
So it's September.
Oh, hold on.
I hate Stop touching me all the time.
Oh, I know what I didn't do. Second entry. Minus 37 times 12. So it's going to be in. So it'll be in the. So it'll be in 2037. What is 9? Is it September? September. Let's see here. Minus 9. How many days in September? 30? 30? On the 23rd day. 16, what is that? Military time. At 4? At 4? Tell me math is not fun.
Divided by, no, times.
At 421.
That's what's
We
Uh,
found out the exact day.
What's it called? 2037 times 16.
No.
we'll leave it. We'll leave it there, and we'll say approximately.
Yeah, that's our high school reunion.
So it'll happen approximately in the year 2038, September 23rd at 4:21 p.m.
That's when the last baby will be born.
2037.
Oh, sorry. Yeah, 37. My bad.
That's our high school reunion.
I'm gonna be dead by then.
2037. I'm September 23rd at 4:21.
Who says math isn't fun? Oh, what a good time. All right, cool. Let's move on. Let's try this. This you'll hear a lot about. You people that are going to go into sciences and stuff, you're going to be my scientists. The half-life of strontium-90 is 28 years, meaning that after 28 years, you're going to be given the amount of substance will have decayed half of the original amount. Find the exponential decay model for strontium-90.
What is strontium-90?
I don't know, but I don't want to touch it.
Element.
With a 90-foot pole. While you calculate this, I'm going to find what strontium-90 is. Because I want to learn it.
That's where you always stick to your. Yeah, stick to your dumb thing. I didn't even realize that it was missing.
Strontium-90 is the chemical element of atomic number 38, a soft silver-white metal of the alkaline earth series. Oh, is it used for batteries?
No,
Alkaline?
that's
There's alkaline batteries. Alkalines are used on batteries, aren't they?
Actually, it is iron that rusts, so it's not. It's just turned into copper. It is
Why not?
iron.
Why not?
Yeah, there's no evidence of equation, so the iron.
Waterfalls! Expectation is you're trying to figure this out right now. Okay, there's a model there you need to find. Think about it. I welcome you turn to your neighbor and you talk about it, try to figure it out. All the information is there, believe it or not. All the information is there.
So it is. Wait, how many? So that's 56. So I think A would be 56.
Well, this software costs as much as the calculator, the one that I have. There's a version out there that is a simulator that you can install. That's why only if you're home.
It would have to be 0. We're trying to find.
Yeah, that's hard. I like this one. I like it. The difference is actually this will do a lot more things. Like I have more applications
They would have to use
for
like predictive.
if I want to use like statistics. This will do it. This will do calculus. Well, this will do calculus. That's like as regular calculus. As some calculus. Now, the better of the calculators is going to be the TI Inspire.
Thanks, by the way.
It will actually do 3 decimals.
Total it has 56
It's
years.
really awesome. I'm a calculator geek, so I collect them.
After
The only thing that I don't have right now, I have a few that I don't have. But I want them because
courage, the cowardly dog.
I have Casio, Texas Instruments, but I don't have
That show is great.
my coolest one.
Paintings came to life and had dinner with
Yeah,
them.
91. It's like I'll show it to you right now. I got it. I actually got it at Goodwill. No, Savers. Remember what Savers was? I've never told you about that.
You only told me,
Did
you know.
I tell you about that?
Yeah.
Yeah, my TI-91. I feel bad. Actually, I don't feel bad, but I kind of feel bad sometimes. It's a business anyway. They were for profit, so it's like it was Goodwill or something. Yeah, they were selling for like $20-some, which was even a steal on its own.
So you stole it anyway?
No, I didn't steal it. Like, all right. So, anyways, she has me behind a case, and I tell her, I say, hey, is that work? She says, I don't know, let me get some batteries. So we put it on, and when it comes on, the screen is just completely like blue. And you smartphone people users, what happens if the whole screen is one color?
You put it in rice.
You put it in rice.
You
It's
try
broken,
cooking
right?
box.
So I'm like, oh, this doesn't work. She's like, well, if you really want it, I'll give it to you for half the price. So I'm like, half price, like, all right, you know, for like, it was like $24, I got it for 12. Like, yeah, I'll take it for $12. But I already knew that if you pull batteries from that 91 model, the contrast would automatically go to full, and that's what she was looking at, was full contrast. So I just told my wife. She said, "Why'd you buy that broken thing anyway?" I'm like, "It's not broken, but check this out." And then I just started turning the contrast down, and it was working just fine. She's like, "What? You're horrible." I'm like, "Yeah, I know." But you know what I did with that other money is I bought the cover for it. I'm a big calculator fan, guys. I'm a big geek. All right, any ideas here? I see you guys. I hear those pencils writing so much, you're all gonna cause a fire by friction. So you need to slow down. Okay. So here, let's stop and think about this. What's our model for growth? A is equal to A naught e to the kt, correct?
Yeah.
So it says the half-life of strontium is 28 years, meaning that after 28 years, the given amount of substance will have decayed half the amount, right? So what's my time frame here? So what's my t? 28. 28. So if I start off with 1, let's say it's 1 particle of whatever it is, right? How much am I going to end up with after 28 years? Half of that. Right?
That makes sense.
So now let's do it. What?
So you didn't.
You do the same thing.
Yeah, and then we just do the same thing as before. Do we really need to divide by 1 though? No, so that's gone. So we're going to do ln. That'll give me ln 0.5 is equal to 28k. Divide both sides by 28. And my constant here, or my k, growth value is going to be whatever ln 0.5 is divided by 28. Wasn't that hard, was it?
What is,
I just didn't think about it that way.
what does that say in the second line?
ln here?
No, the
Here?
second, yeah.
This was a 1. It was a 1. But then I said, do I really need to divide by 1? Like, not really, so I turned it into ln e. So we should have,
The piano riff that goes in the beginning.
Now that number's familiar. Didn't we see that before?
Oh yeah.
Oh yeah.
How's it doing in the bathroom, dog? All I got is bread.
Have your people call my people? Oh, what's wrong with my problem? What's wrong with my model, yo? What's wrong with my model?
There's no E.
Yeah, I missed the E. Gotta have the E. And no, I didn't do it on purpose. I didn't do it on purpose.
You put A minus.
Oh, I did. I'm just dropping the ball all over the place. Wow. Anything else I messed up?
Nah, that's fine. It's good.
It looks right at this point. Cool beans. Write this down, yo. Mathematical model for limited logistic growth. Limited logistic growth. I know, huh? You can. So when your mom asks you, "What'd you do today?" We learned about limited logistic growth.
In 5 minutes,
Or you can just say nothing,
I'm gonna
like you always do. What'd you do today? Nothing.
leave this class.
Good thing I didn't have a.
My parents never done that.
It's like, hey, there's dishes going.
Like, hey, idiot, start doing your chores. Or actually, she was first.
Make sure that door shuts behind you. Oh, it did. Thank you. Pop, lock it, drop it. is, it's tails.
Oh. Gosh.
Stopping it.
Write it down. Formula.
Oh, you said
Sounds like you have it. Waterfalls. Here's your next one. This is the, wait, where'd it go? Oh, there it is. This is called, oh, it doesn't have the name up there. Sad face. This is called Newton's law of cooling. Newton's law of cooling. Newton, like big Newtons? Not the mathematician. Newton's law of cooling. Oh, I thought you had some brain freeze over there.
I never watched Hercules.
Can use the restroom.
It doesn't fit in either end of the country.
it's on Netflix.
You underestimate how little I watch movies.
Please make sure you get the verbiage here. This is important to know because C is the constant temperature in the room. There's two positions for it. T naught. What is T naught? Yeah, you should always know that, right? Whenever you see a T naught, that's your starting point. So that's going to be the temperature where it starts. K is a negative constant that's associated with the cooling object. And then this, of course, should be the temperature that you get at the end.
Wait, what's C?
C is the constant temperature in the room. So like the temperature that's in here right now, that's what it would be. Do you want me to erase that green stuff? You like the green stuff? Can you see well with the green stuff? What is little t, guys?
Time.
You're so smart.
The T is
I was gonna say little temperature.
Little temperature? That's funny because it's cooling.
Feels like your lotion to me.
That is so cooling.
Dude, sometimes my laugh sounds like ha 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 ha, and like I don't need to be bursting. I'm just like.
I like stuff.
We're good?
I would have made him lose 100.
All right, check it out. Here's an example on Newton's law of cooling. Can you guys just plug and chug? You guys okay with plug and chug? Do we need to do it? That way we can be done, huh? Because I'm running out of stamina here.
Yeah, I'm good at plugging and chugging.
Whoa! I'm so weak.
What if I was next to the door? What if I was next to the door?
You would have been dead. You would have been crushed. Your internal organs would have burst.
Disintegrate.
Did you hear me through the door?
Yeah, I heard the footsteps coming in.
Oh, ow.
Okay, that's not what I meant. Alright, I'll see now. I can leave it.
chug? Or we know plug and chug?
We know.
We're doing it. Okay. An object is heated at 100 degrees Celsius. It is left to cool in the room that has a temperature of 30. What is my 30 here? That is my C, right? So I'm going to do 30 plus or minus, plus something minus the 30 here as well. E to the, after 5 minutes,
So
Ooh.
E to the 5.
no, that should be 5. Hold on.
Wait, how do you? Time would be 5.
Oh, T O would be
TO would be 100. TO is 100. The T is temperature. At the end is 80, and the time is 5.
What is 5? It is minutes. Sorry, usually when we do time, it's always in hours. That's why I had to check that. So it is going to be 5. We're looking for K. And it's heated at 100? There it is. Thank you. What is that, 70? So we've got 50.
What's your name?
Right? How are we going to get rid of this E? We're going to ln it. 80 minus 30? Sorry, I did skip that. Should I go back and redo it?
No, I realized as soon as I said it.
Okay. So now we have ln 50, the 257.
Oh, yeah. Just 1 second.
Because the 70 is connected to the to the 5.
Sorry, I skipped a lot of steps on there. Is there any questions? Please let me know. Just kind of got excited. Huh?
What am I doing?
Are we good? No, wait.
Yes.
Okay. It's just one more formula that you need to get to. I want to make sure we cover it. Right, Maddie?
Exactly.
What'd you get?
I wonder why.
I'm sorry. I couldn't help myself. Hey, I'm rude. You can't leave what?
I was like, the letter it was
You look like a little chiquita. Leave me alone, it's my life. You, Maddie. Leave me alone, it's my life. I want. Isaac. You're supposed to do the popping thing.
I don't like that.
I know. Last year at the end of the semester, it was really big. Are we good here? Can I change it? I gotta give you a formula. One more formula. Yeah? Okay. You got it? We're good then? Okay, here's what you need to know. Expressing y equals a times waterfalls. You need this as well. You need to know how to express y equals a times b to the x in a base of e. These two forms are equivalent. Make sure that you note them, please. That should make sense to you, right? Because a base e taken to a natural log are inverses of each other. So you just get that b part.
That's
Yeah.
the word I always forget. I always want to say opposite, even though it's like
Log natural.
Yeah.
I know. Okay, as you wrap that up, please make sure you do the exit ticket. jmunoz.me/exit.